2.5 Measures of Position. Quartiles. In this section, you will learn how to use fractals to specify the position of a data entry within a dataset. Fractals are numbers that partition or divide an ordered dataset into equal parts. Each part has the same number of data entries. The median is an example of a fractal. Remember that we had already gone over how to find out the median of a set of values. So the median is an example of a fractal because it divides an ordered data set into two equal parts. There are three quartiles. So since quartiles is an example of fractals, it's just a way of dividing a group of values or a set of values. We're going to go deeper into how to find a way to divide a set of values into quartiles, into quarters basically. So there are three quartiles that divide an ordered data into four equal parts. Q1, Q2, and Q3 mean the first quartile, the second quartile, and the third quartile correspondingly. Q1, it measures or it counts about 1/4 of the data that falls on or below that value. It could be up to that value or any other value that is less than the actual Q1 or first quartile. The second quartile or Q2 goes or contains about 1/2 of the data that fall on that number that you consider to be the second quartile, or any value that is below or less than the actual number that is Q2. Note that the second quartile is actually always going to be the same as the median of the data set. So when you, in the past sections, were calculating the median of a set of values, in reality, you were finding the second quartile of a set of values. It's just back then we were not yet introducing these new definitions or this new vocabulary. Q3, it's about 3/4 of the data that fall on or below this number that is going to be Q3. So this is the definition. Basically, if you want to divide a set of values into four equal parts, you're going to divide them by using quartiles. And what are the three values that you need to find out in order to divide this set of values into four equal parts? The first, the second, and the third quartile. So here is an example of finding quartiles of a data set. It says the number of the nuclear power plants in the top 15 power producing countries in the world are listed. Find the first, second, and third quartiles of the data set. What do you observe? So you see the listing of the numbers that represent the number of nuclear power plants in the top 15 nuclear power producing countries in the world. Notice how all these numbers are not setting up in any particular order. So in order for you to find the first, second, and third quartile, it says here, first, order the data set, put it in order from least to greatest, and find the median or the second quartile. That's going to be the first thing we have to do. So we have to put in order all these numbers. So start with the least number from all these values. That would be the number 6. So I'm going to be scratching off the ones that I'm already putting in order here so that I don't repeat them. Then we have a 7. Then we have 8. Next number would be 9. Then we have 10. Yeah, 10. Then we have the next number being 15. Then we have the 16 twice. Then we have the next number, there's twice 20. So 20 and 20 again. Then we have 23, 33. Lastly, well, almost 50 and then 104, right? So 50 and 104. Okay, so now that you have put all your data values in order from least to greatest, the first thing that you're always going to find is the median or the second quartile. In order for you to find the median, if you remember in previous sections, I gave you a little formula that can help you figure out the position of the median. So I'm going to write here, position of median. You can find this out by doing this little formula, n plus 1 divided by 2. N means the total number of values that you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I missed a value. I just realized here it's 58. Sorry. I was like, they're supposed to be 15 and I was missing one number here. So between, let me try to make these numbers a little bit less big. So after the 33, the next value was supposed to be a 50. The next one was supposed to be a 58. Sorry about that. And then the last one, 104. Oh, I'm going to put it up here, okay? Because these arrows are not going to let me write on it. So the 104. So now if you really count, there should be 15 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. This one is up here because these arrows would not let me write in here. So I apologize for putting the 104 up there. So the formula for finding the position of the median is n plus 1 divided by 2. N is the number of the total number of values in your data set. So we have 15 values plus 1, whatever I get, I'll divide it by 2. So 16 divided by 2 is going to be 8. This 8 means the 8th position. So it means that the number in the 8th position, counting from the least to the greatest, obviously from left to right, that's going to be what the actual median or Q2 is going to be. So if we start from the 6th, 1, 2, 3, 4, 5, 6, 7, 8. This one, I'm going to put an arrow here. It's my median. But remember that the median is actually the same thing as the second quartile all the time. So okay, first order the data set. We already did that from least to greatest, and find the median or the second quartile. We already did that. The first quartile is the next thing you're going to find. So the first quartile is the median of the data entries to the left of the second quartile. So basically what you have done right now with identifying this number as being the median, count how many values are to the left-hand side of the median. 1, 2, 3, 4, 5, 6, 7. Count how many values are to the right-hand side of what you say is the second quartile or the median. 1, 2, 3, 4, 5, 6, 7. And that's the way that it's supposed to be. You're dividing right now by the very center of this group of values in a way that the left-hand side and the right-hand side contain the same amount of values. Not any side should have more than the other one. Because you know that means we didn't really find what's the median or what's the second quartile. This one has to partition, has to divide all my group into the same number of values to the left-hand side than to the right-hand side of this value, of the second quartile. So now what you're going to do is, you could repeat this formula again, like if you were to find the median again for all the values, only taking into consideration all the values that are to the left-hand side of the median, or this 16 that we circled before. So it's just that if you're going to do the formula again, you need to count how many values are to the left-hand side of the 16 that we circled without counting the 16. 1, 2, 3, 4, 5, 6, 7. So if you do the formula, 7 plus 1 is going to be 8. 8 divided by 2 is going to be 4. So 1, 2, 3, 4. This number right here, count how many values are to the left-hand side of that number. 1, 2, 3. Count how many values to the right-hand side from the 9, but before the Q2. 1, 2, 3. So then this is my Q1, my first quartile. This is the median of its own little subgrouping here from the 6th up to the first 16, let's say. The same thing you can do here. There's 7 values, so following the formula, 7 plus 1 is 8. Now I'm trying to find the median for this subgroup over here to the right-hand side of the Q2. So 7 values again, plus 1 is 8, divided by 2 is 4. So starting counting here, 1, 2, 3, 4. This is going to be my Q2. So I really didn't write the formula again because there wasn't a need for you to say 7 plus 1 is 8, 8 divided by 2 is 4. You could also have seen like the number that partitions or that cuts or divides this set of values into exactly the same number of values to the left hand side and to the right hand side. It's with respect to this 33. 3 values to the left hand side, 3 values to the right hand side. Same thing with the 9. 3 values to the left hand side of the 9, 3 values to the right hand side. So you have your 4 quarters. You divided this into 4 equal parts, right? So the first quarter goes up to 9 or any number that is less than 9. The second quarter, it covers all the way since the beginning up to 16 or any number less than 16. The Q2 or the I'm sorry, this wasn't Q2, this was Q3. I had already found the Q2 over here in the middle. This is Q3, the third quartile. So up to the third quartile, it's up to the number 33 or any value that is less or below than the 33, right? So that's basically how you find the 3 quartiles that are dividing your entire group of values into 4 equal parts. Okay. So it says here, like an observation in the context of the situation of this problem. About 1/4 of the countries have 9, I'm just reading here below, or fewer nuclear power plants. About 1/4 of the countries have 9 or less than that number of nuclear power plants. It also says about 1/2, so up to the 16, because this is half of the values, about 1/2 have 16 or fewer, and about 3/4, this is the first quarter, second quarter, third quarter, so about 3/4 have 33 or fewer. Okay, so basically that's how you find your 3 quartiles. So now we're gonna extend this a little bit more. There's something that is called interquartile range, or abbreviated IQR. This, it says here, that is a measure of variation of a data set that gives the range of the middle portion, or about half of the data. Thinking on the context on the previous problem, the middle portion, you would be analyzing, or you would be referring to the number from the Q1, from the 9 all the way up to the 33, up to Q3. That would be the middle portion of this group of values. So the IQR is the difference between the third and the first quartiles. If you want to find the IQR, or you're ever asked to find the interquartile range, you need to know what's the Q3 in your group of values and what is the Q1, and subtract them. Guidelines, and then it says here, an outlier was described before in previous sections as a data entry that is far removed from the other entries in the data set. One way to identify outliers is to use the interquartile range. We have said before that an outlier is a value that is so far away from where the majority of the values are. So here are specific steps for you to find exactly which values from your group of in your data set may be outliers. So here are the guidelines to identify outliers by using interquartiles, by using this formula. Number 1, find the first quartile and the third quartile. You already know how to do that from the data set. That's what we just learned in the previous example. Number 2, find the interquartile range. You need to find this too, because then you're going to use this formula and you need these two values to subtract them from each other, Q3 minus Q1. Then step 3, multiply the IQR, so multiply the answer that you got from this subtraction times 1.5, or 1.5 times the IQR. The order doesn't matter, IQR times 1.5 or vice versa, 1.5 times the IQR. Number 4, subtract the multiplication of 1.5 times the IQR from Q1. Here is the formula, basically. Q1 minus 1.5 times IQR. This 1.5 times IQR, you had already done it in step 3. All you're doing is subtracting that answer from step 3 from the first quartile, from Q1. It says here on number 4 that any data entry that is less than the answer of this subtraction, you're going to consider it an outlier. Number 5 says that the multiplication of 1.5 times the IQR, when you add this answer to Q3, here is the formula, Q3 plus, instead of minus, the multiplication of 1.5 times the answer from step 3, from step 2, I'm sorry, times the IQR, is going to be an outlier. So any value that is less than this formula, any value that is greater than this formula will be considered an outlier. And that's what you're doing here, finding any possible outliers. So example 2, which is about using the IQR, or the interquartile range, to identify an outlier. Find the interquartile range of the data set in example 1. Are there any outliers? So using this set of values, the same example, it says that I need to find if there are any outliers. So we're going to do all these steps in order to figure that out. So I needed to know first what was Q1 and what was Q3. So Q1 was 9 and Q3 was 33. Where am I getting these numbers? I'm just going back to the first example. Q1 is 9, Q3 is 33. So I had already done first step. Second step, find the interquartile range. So now I'm going to use the formula. IQR is equals to the subtraction of Q3 minus Q1. So 33 minus 9, and was it really? Sorry, I just wanted to make sure that I was not copying the wrong numbers, but yes, Q3 was 33, Q1 was 9. Okay, so then 33 minus 9 here, 24. So this was my step 1, identifying Q1 and Q3. This was my step 2, calculating the IQR by subtracting, by following the formula. And then step 3 says to multiply 1.5 times the value of IQR from the previous step. So then why 1.5? That's part of the formula. Always is going to be that number. 1.5 times 24 in this case. So let me do it in my calculator. 1.5 times 24, that's going to be 36. This 36, you're going to use it for step 4 and for step 5. So for step 4 says you're going to consider as an outlier any value that is less than this formula. So let me copy that formula here. Q1 minus 1.5 times the IQR. This multiplication of the 1.5 times the IQR you already did in step 3, which was 36. So basically 9 plus the 36, right? The 9 being the Q1 and the 36 is the multiplication of these two things. So this would give me a 45. Then 5 says Q3 plus 1.5 times the IQR would be 33 plus the 36, so this would be 69. So it says that I just got myself doing a careless mistake. I don't know, this formula has a minus and I don't know why I put a plus here, but it was supposed to be a subtraction. So it was 9 minus 36, not 9 plus 36. 9 minus 36 here, that's the minus that I had here. So this is a negative 27. So any value that is less than negative 27, or any value that is more than 69, is what is going to be considered an outlier. So now I'm going to go back to my original values. So do we have any value that is less than negative 27? If you look at the numbers that we have We don't even have negative numbers here. So how could a positive number be less than negative 27 than a negative number? No. So we have no number here less than negative 27. So that is not going to give me any outlier in this scenario. Not that it's wrong that you got a negative answer. That's not the problem. The problem is in my set of values, I don't have any number that is actually less than negative 27. But I do have at least one value that is more than 69. So that would be this 104 over here. So 104 is an outlier. So here, the number of power plants in the middle portion of the data set vary by most at 24. It says that the difference between the number of nuclear power plants in the middle portion, so from 9 up to 33, the difference between them at most, the most difference or the highest difference is 24, that it's no bigger than 24, which was the subtraction of the 33 minus the 9. But then the second part is, notice that the outlier is 104, because that's the only number that I was actually able to find that was either less than negative 27. We said there's no value less than negative 27, but I was able to figure out a value that is more than 69, which is the 104. But it says that this does not affect the IQR. So bottom line, this is the outlier, the value 104, because it's a value that is more than 69, more than the answer of this formula. Okay. And we're getting here towards the end. So now that you know how to divide a set of values into quartiles by finding first the median, which is Q2, then finding the median again of the values to the left-hand side of Q2, and then finding the median again of the values to the right-hand side of Q2, and that's how you find Q1 and Q3, right? Now we're going to put this in a graph. So another important application of quartiles is to represent data sets using a box and whisker plot. They are an exploratory data analysis tool that highlights the important features of a data set. In order to do a graph, the graph of a box and whisker plot, you need the following values. You need the minimum entry, that means the smallest value. You need to know the first quartile, you need to know the second quartile or the median, you need to know the third quartile, and you need to know the maximum entry or the highest value. So we, like first one and the last thing, they're easy. Lowest value, highest value. And you already know how to figure out these three from the problem that we just did at the very beginning. So guidelines are the rules for drawing a box and whisker plot. Number 1, find the 5-number summary data set. What are the 5-number summary? These are the 5 summary data set values. 2, construct a horizontal scale that spans the range of the data. Okay. So this horizontal scale would be this line that is right here. What is the range of the data? In previous sections we learned that the range means the subtraction of the highest value minus the smallest value. That's why at some point you need number 1 and number 5 from the 5 summary data set. 3, plot the 5 numbers above the horizontal scale. Plot these 5 numbers, it says above the horizontal scale. 4, draw a box above the horizontal scale from Q1 to Q3 and draw a vertical line in the box at Q2. Draw this box that you see here in light blue above the horizontal scale from Q1, here is Q1, up to Q3, and draw a vertical line in the box where Q2 is supposed to go, where the median is supposed to go. 5, draw whiskers from the box to the minimum and maximum entries. Whiskers are these lines that you see here. Okay, this is the whisker and this is another one. So where this whisker starts, this should be the lowest value in the data set, and where this whisker ends, this should be the maximum value in the data set. So let's see the example that is on the next slide. So if you want to draw a box and whisker plot that represents the data in the data set in example 1, so we would be talking about this one right here. So I'm going to need to know the Q2, which I already know it, the Q1, the Q3. I would need to know what is the minimum, which is the 6, what is the maximum entry, which is the 104. So I have all the information that I may need for doing this. So I'm going to put a horizontal line. Then here, my max entry, my minimum entry goes here. My maximum entry goes here, right? So I'm just going to be labeling it here. Min, max. Then I'm going to need to draw this box, just like do some sort of estimation. So Q1 is supposed to be actually the number 9. You started with the first whisker on the left hand side at 6. So you can estimate more or less, let's say, just like thinking of spaces of 1 unit at a time. 7, 8, 9. Let's say that here I'm going to draw this box, and this box actually has to go all the way up to where Q3, look at how this graph looks like. Q3 is where the box is going to end. So Q3 was the number 33, and then the whisker on the right hand side goes up to 104. So more or less, let's say, actually I'm going to erase a little piece. Let's say here I'm going to say this is where the 33 is going to be. So we close this box. So this one is going to be the value 9. This one is going to be the 33. So this is my Q1. This is my Q3. And then the median, which was the 16 in here, I'm going to draw a vertical line through where 16 is supposed to be. And again, just more or less, you can do an estimation. So let's say that it's going to be somewhere 10, let's say 10, 11, 12, 13, 14, 15, 16, more or less here. I would say that's where more or less 16 would be. So 16, and this is the Q2 or the median. And that's basically it. That's all you need. Yeah, you have your Q1, your Q2, your Q3, your minimum, and your maximum. Now here is just a little explanation that says the box represents about half of the data. This was meant to be off. The box represents about half of the data. Within the box, about half of the data is here contained within the box. You already knew that because we have already said that from 9 up to 33, this represents 2/4 of the 4 quarters. So this is half of the data from 9 up to 33. And those are the values that are contained within the box from 9 up to 33. So that's why this says that the box represents about half of the data. That's one thing that you can see here, which means about 50% of the data entries are between 9 and 33. Yep. And then it says the left whisker, so this one, represents about 1/4 of the data. Yes, because the first quarter, if you remember in the list of values, was going from 6 up to 9. So 6 up to 9, first quarter. And that's what the left side whisker represents. So left whisker represents about 1/4 of the data. That means about 25% of the data. That's 1/4 of 100%. So 25% of the entries are less than 9, right? From 9 or less. The right whisker represents about 1/4 of the data. From 33 up to 104, that was the last quarter. From 33 up to 104. So then it says that the right whisker represents about 1/4 of the data, so another 25% of the data entries are greater than 33, from 33 to 104. Then it says also the length of the right whisker, this one, is much longer than the left one. And what about that? The whisker, and not always is going to be the one on the right hand side, it could be the one on the left, the one that is the longest from both. But in this case, the longest from these two is the right hand side whisker. This indicated that the data set has a possible outlier to the right hand side. So to the side where the whisker, the left or the right, is the longest, that's possibly on the side where you're going to find an outlier. And yes, it's true, because our outlier was the number 104. We already knew that from before. And it's on the side where the longest whisker is, which is to the right hand side. So this is the end of what you need from section 2.5 for the test that you're going to be taking this Thursday. It's only this. I know that this is not the entire 2.5 section, but we will cover that section Tuesday of next week, just for you to be able to complete the homework. But up to here is what you need to know from 2.5 for the test.